Today we are going to discuss the topic how to balancing redox reaction. The first method is oxidation number method. Now today we are going to see the topic oxidation number method. Using this oxidation number method, how to balance the redox reactions. Step 1. Using oxidation number, identify the reactant which undergo oxidation and reduction. So, we have to find out the atom which undergoes oxidation and reduction. Oxidation means losing of electrons, reduction means gaining of electrons. So, you have to find out oxidation and reduction atom in that equation. Step 2. Calculate the number of lose and gain of electrons and identify number of atoms which undergo oxidation and reduction. In the step 2, we have to calculate number of lose and gaining of electrons and also the number of atoms which undergoes oxidation and reduction. Do cross multiplication in that reactant side. Step 3. Balance the reactant and product oxidized and reduced. So in the step 3, you have to balance the atom which undergo oxidation and reduction. You have to balance only what? The reactant side and product side. You have to balance oxidized and reduced atom. In the step 4, balance other atom, expect hydrogen and oxygen. So if you are having any other atom in that equation, you have to balance that atom, expect hydrogen and oxygen. Step 5, now balance hydrogen and oxygen atom. In last, you have to balance the hydrogen and oxygen atom. So step 1, you have to find out the atom which undergo oxidation and reduction. Step 2, we have to calculate number of electrons and number of atoms which undergo oxidation and reduction and do the cross multiplication in that reactant side. Step 3, balance reactant and product side. Balance the reactant product side, the atom which undergo oxidation and reduction. Step 4, balance other atom, expect hydrogen and oxygen. Step 5, now balance hydrogen and oxygen atoms. For example, we are having the equation here. Here in the reactant side, Fu is in the +2 oxidation state. This is the reactant side. This is the product side. In the product side, Fe is in the +3 oxidation state. So, oxidation state of Fe changes from +2 to +3 by losing 1 electron. So, iron undergoes oxidation by losing how many electrons? What is the difference between oxidation state? Here +2, here +3. So, difference is 1. So, iron changes from +2 oxidation state to +3 oxidation state by losing 1 electron. So, it undergoes oxidation. Then come to the next, KMnO4. Here manganese having +7 oxidation state in the reactant side, but in the product side manganese have +2 oxidation state. So what is the difference between the oxidation state? +7 minus +2, we are getting 5. So 5 electron. So here manganese gaining, attracting 5 electrons and changes to the +2. here it comes reduction. So manganese changes from +7 oxidation state to +2 oxidation state by gaining 5 electrons. Okay. So step 1 is what? So here iron undergo oxidation reaction, manganese undergo reduction reaction. Iron changes from +2 oxidation state to +3 oxidation state. Manganese undergo manganese changes from +7 oxidation state to +2 oxidation state. Okay, one. Next, step 2. Step 2. Calculate number of loss and gain of electrons. Identify number of atoms which undergo oxidation and reduction. So now see that equation. FeSO4, Fe2SO4. Fe having +2 oxidation state. Here Fe having +3 oxidation state. So difference is 1 electron. So we have to specify here 1 electron. KMnO4 in the reactant state. The reactant side Mn is in the +7 oxidation state, but in the product side Mn is in the +2 oxidation state. So what is the difference? 5 electrons. So you have to specify here 5 electron. So and so now we are finished calculating the number of electrons loss and gain. So next you have to calculate number of atoms which undergo oxidation and reduction. In the reactant side you are having 1 iron atom, but in the product side you are having 2 iron atoms. So you have to multiply 2. 1 electron into 2 and 5 electron into 2. Okay. So in the step 2 you have to calculate number of electrons and number of atoms. Okay. Then doing cross multiplication. You are getting 5 into 2 10. 10 FeSO4, 2 KMnO4 plus H2SO4. Remaining balance like that. Fe2SO4 thrice plus MnSO4 plus K2SO4 plus H2O, like that. Okay. Step 2 finished. Next, step 3. Balance oxidized and reduced atom. So you have to balance number of oxidized and reduced atom. So here you are having 10 FeSO4, but in the reactant side you are having only 2 iron atoms. So you have to put 5 in front of the Fe. So you have to put 5 Fe2SO4 thrice. So now it balanced. 10 FeSO4, 5 Fe2SO4 thrice. Here you are having 10 Fe, 5 into 2 10 Fe atom. So now iron atom balanced. Next KMnO4. Now you are going to balance reduced atom. Number of reduced atom. We are having 2 manganese here. The 2 is common for both, common for all the atoms. Potassium, manganese, oxygen. So we are having 2 manganese atom in the reactant side, but in the product side you are having only 1 manganese. So we have to put 2 in front of the manganese. Okay. So 2 KMnO4, 2 Mn balanced. So now manganese and iron gets balanced. Get 10 Fe, here are 10 Fe, here 2 Mn, here 2 Mn. So after balancing the oxidation reduced atom, then go to the next step 4. You have to balance other atom in the reaction. So you are going to balance potassium and sulfur atom. Potassium itself is balanced. Here 2 potassium atom, here 2 potassium atom. So it is equally balanced. So now you have to balance sulfur atoms. Reactant side we are having 10 sulfur atom. So reactant side 10 sulfur atom. Product side I wrote the product equations fully and calculating the sulfur atoms. 5 into 3 15 plus 2 sulfur plus 1. So total number of sulfur atom 18. So on balancing, so reactant side, product side you are having 18 s electron, but in the reactant side you are having 10 s electron. So reactant side has less electrons when compared to the product side. So you have to add a number of s in the reactant side. So 10 FeSO4 plus 2 KMnO4, we have to add 8 in front of the H2SO4. So now it is balanced. 10s plus 8 vandrum. Okay, 10 FeSO4 plus 2 KMnO4 plus 8 H2SO4. Remaining balance 5 Fe2SO4 thrice plus 2 MnSO4 plus K2SO4 plus H2O. Okay. Step 4, balance other atom, expand hydrogen oxygen. Potassium itself it's balanced. Reactant side you are having 10 sulfur atom, but in the product side you are having 18 sulfur atom. So reactant side having more sulfur atom. So for to balance this you have to add number of 8 electrons in the 8 sulfur atom in the reactant side. So you have to put 8 in front of the H2SO4. Now number of sulfur atom is balanced. 10 plus 8, 8 sulfur atoms, 15 to 1. 18 sulfur atoms. Now step 5, balancing hydrogen and oxygen atom. Reactant side you are having 8 H2SO4. So now we are going to balance one hydrogen atom. So 8 into 2 gets 16H. Product side H2O, 1 into 2 gets 2. Final reaction 10 FeSO4 2 KMnO4 plus 8 H2SO4 gives 5 Fe2SO4 thrice plus 2 MnSO4 K2SO4. So you have to put 8 in front of the H2O. So 8 into 2 16, 8 into 2 16. So hydrogen balanced. 8 into 2 16, 8 into 2 16. Hydrogen atom balanced. Oxygen itself balanced. Here you are having 8 oxygen atom. 2 into 4, 8 oxygen atom. Here you are having 8 oxygen atom. So the reaction is now satisfied and balanced. Okay. So you have to calculate all the number of atoms balanced or not. Thank you.